So straight lines have a constant slope. That tells you how fast the y value is changing. It tells you how fast it's increasing or decreasing. But we can find average rates of change of any function. And the way that we do that, so here we have a function square root of 2x minus 4. It gives us this graph right there. And we can find the average rate of change over the interval 2 to 10 by plotting a point at 2, plotting a point at 10, and then finding the slope of the straight line that goes through those points. This is called a secant line. And we know how to find slopes of straight lines, right? The slope of the straight line is change in y over change in x. So what's the y value at that point? It's your function value at 10. What's your y value at that point? It's your function value at 2. Your x value at that point is 10, and your x value at that point is 2. Right, so this is change in y over change in x. It's the slope of the secant line, the straight line that connects those 2 points on your function. Okay, so let's go through the algebra. F at 10, that will be square root 2 times 10 minus 4. We then subtract f at 2. So it'll be square root 2 times 2 minus 4. And then we divide by, let's go ahead and tell ourselves what 10 minus 2 is. That's 8. All right, so in the function value at 10, 2 times 10 is 20, minus 4 is 16. Square root 16 is 4. The second square root, the function value at 2. 2 times 2 is 4. 4 minus 4 is 0. Square root 0 is 0. Right? Again, it looks like the function value was supposed to give me a 0 there anyway. Turns out the equation says that that's right. The function value at 2 is 0. So we go through this algebra and we find the change in y over the change in x of that secant line, or the average rate of change of this curved function over that interval is 4 over 8, or 1/2. So on average, even though it's increasing pretty steeply right there, and then it slows down, and then it slows down even more, on average, that function increases at a slope of 1/2.